Now we try to look at the set of all words that contains as many zeros as 1. For example, we have language, where 0 and 1s are part of it, and the count of 0 is equal to the count of 1 is not regular. So first of all, the opponent controls the j. The pumping, let's assume he chose j equals to 5. And the initial string, you must pick a word like in the language with the length that is bigger than or equal to j. Since j is equal to 5, let's choose n equals to 5. This is what we choose. And we put this n on the p, which is the total length, and separate, because we cannot have, we can only store things in a variable. We cannot have them without a variable. That's why we do it. Now what happens is that we know that n is a separate block. So p, for example, is equal to 0 to the power of 5 and 1 to the power of 5, which totals us with 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And our total length is 2j equals to 10. We know that we have 2j's, for example, 0j and 1j. This is our word, p equals 2. This is what we did, basically. And based on that, the UVW is the split that, again, he decides. He decides where to put the UVW. And I can only decide, but UVW needs to follow the strict rules that we mentioned. But I get to decide the I part, and I make I equals to 2. Now the opponent absolute constraint is that U and V needs to be less than and equal, the length of this needs to be less than equal to j. And because they choose 5, the first two pieces U and V must be chosen from the first 5 characters of the string. So 1, 2, 3, 4, 5. This needs to be chosen from strictly from this, because UVW is the situation, and UV needs to be less than or equal to j. Our j is 5. It definitely needs to have, and we cleverly choose a word that is in the sequence, just like this, for example. And now what happens is that, looking at the string, the first 5 are all zeros. This means no matter how creatively the opponent slices the string, the pumpable V is guaranteed to consist of entirely zeros. So the setup is that the opponent chooses j equals to 5, and I choose my initial p, length 10, and we know that this consists of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is perfectly in the language because it has exactly 5 zeros and 5 ones. Now the opponent moves the split. The opponent picks a split where UV is less than equal to 5 and V is bigger than equal to 1. UV is less than equal to 5, which is the j, and V is bigger than equal to 1. Since the first 5 characters are 5 zeros, they have no choice but to take the zeros for their pump. Now what happens is that they take 2 zeros here, and they might take 3 in V part, and they can vice versa it, but it doesn't matter. It still is the length of 5. They can decide within the 5 diameter, just like here. And based on that, we have the remaining W. Let's check the tracking variable R and the length of V. We know that V equals to 3, because this is our R, and this is legal because R is bigger than 1, and UV combine are equal to 1, 2, 3, 4, 5, which is less than equal to the j, which is 5. Now the winning move is that I choose a pumpable multiplier I equals to 2. What it does is that UVW, where it becomes 2 here, and the new length becomes U plus V plus W, which means 0, 0 plus 0, 0, 0 plus 0, 0, 0 plus 1, 2, 3, 4, 5. We knew that our V had 3 here, and 3 is of course bigger than 1 or equal to as well. And based on that, it follows all of the rules, and now this is our new string. And it becomes 0, 0, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. And now why do I win in all splits? Let's count the character of your new string. The zeros are 8 and the ones are 5. Based on that, the language rule states that the number of zeros must perfectly match the number of ones, and because 8 is of course not equal to 5, we know that this can never match and the balance is completely broken. And what if the opponent chooses a different split? If they choose a split where r equals to 1, v equals to 0, pumping up yields 5 plus 1, which is 6 zeros. Still not perfect. I still win. If they choose a split where r equals to 2, meaning 2 zeros, then pumping up yields 5 plus 2, which is again 7. And 7 is not equal to 5. The ones. So in that case, if I decide to pump down I equal to 0, the 0 disappears, leaving fewer zeros than ones. So fewer zeros than 1 means I minus r, which is less than 5. The other side, I still win. So because uv less than j forces v to consist exclusively of zeros, pumping the string will change the count of zeros while leaving the count of ones completely frozen at 5. Since every single valid split is physically trapped inside the first block of zeros, all valid splits fail the condition when pumped, and the opponent has 0 safe moves, and the regular pumping is broken, and I win. Now let's look at the next question. The next question consists of all words of balanced brackets. We are proving that the duck language is not regular, and what happens is that we again see that who decides the j? The opponent decides the j. And our language is all words of balanced brackets. This is our language. And j, let's decide j to be 4. I think let's assume he decided it to be 4. We decide p. Our initial string must pick a perfectly balanced string where the number of opening brackets is bigger than or equal to j. Since j is bigger than 4, you choose p equals 4 and closing bracket 4. So this is our condition where we know 1, 2, 3, 4, 1, 2, 3, 4, which is 2 to the power of j equals to 8. We basically did this. We said, okay, we decide this as our word, which is of course a part of the. Now opponent says UVW, the split. The opponent slices up your 8 characters and they must follow the rules of the split. Now I decide the I, and I want I to be 2 to break the split. Now what happens is that real character exampling covering all split. Just like we know that UV is less than j acts as a barrier because the first opponent chooses j equals to 4. The first 2 pieces UV cannot go further to the right than the first 4 characters. Looking at the string, the first 4 characters are all opening brackets, for example. Let's look at it again. 1, 2, 3, 4. 1, 2, 3, 4. And the first 4 are just like, even when he decided the j to be 4, the first 4 are just opening brackets. And based on that, this means no matter how the opponent splits the string, the pumpable part v is guaranteed to consist entirely of opening brackets. And let's look at it this way. This is perfectly valid, the split that we did. The opponent moved to split. What happens is that he says, okay, u is the 2. This is u. Because our j is 4, the uv cannot be more than 4. V gets here. or maybe let's just take the first as V. Now see what happens here. We try to decompose this, and when we try to decompose this, we might say P, these two. Now happens the one part, because we said I to 2, I is 1, I is 2 now. And now when I is 2, and we plus that with the remaining word, this is 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is 5. And this is 1, 2, 3, 4. And the core rule of the duck language is that every opening bracket must have a matching closing bracket. But because we have 4 opening brackets and 5 closing brackets, now based on that, we can completely understand that the length of V is 1. Here, let's try to focus on it. Length of V is 1. This is legal because R is bigger than 1 and UV are 3. For example, you can see UV here are 3, which is again less than equal to 4. So the total length is 8. 2 goes here, 1 goes here, and 5 goes here. Now what happens is that we understand that when we try to pump this side, just we already did, the opening brackets after pumping 1, 2, 3, 4. Now let's just write what we wrote here. 1, 2 after pumping, 1, 2, 3, 4, 1, 2, 3, 4, and then another 5, and now this remaining, which was never pumped. This was also not pumped, this was also not pumped. So 1, 2, 3, 4, and we have 5 opening brackets and 4 closing brackets. And based on that, we know that the duck language told us that the core of that is that every opening must have a matching closing bracket. Because we have 5 opening brackets and 4 closing brackets, the brackets are left unclosed, which completely ruins the balance. And what if the opponent chooses a different split? As we note, if they try to include a closing bracket outside UV, their length UV would have been greater than J, which completely breaks the rule that UV needs to be less than or equal to J. And hence, based off that the pumpable part V must contain only, we know that our J was already 4, and they can only use their split within this section. If they use anything, because we put J on this side, on top of it, so the number of this is equal to the number of the length of what they can choose in UVW, and this is of course the first character. Then we also put on top of this, so if they choose 4, for example, then the split must also be equal to, this is our word what we decided. If they decide we also said, oh, our word is also like this. So if they also said, oh, I wanted to choose 4, then they have to use a split of UV, locking it strictly within this, because it cannot be bigger than 4, meaning that they will always have to decide from this side. They can never go bigger than this side up to the other side. Hence, we know that therefore the pumpable part V must contain only the open brackets, and pumping will create more opening than closing brackets because J plus R is always bigger than J. Hence, every single valid split is physically trapped inside the opening bracket section. Hence, we win this specific situation. Now let's look at WW equals to 0, 1 of asterisk. So the repetition language is not regular using regular expression. We will use exact variable p is the string, j is the pumping length, and r is the length of v, where j is controlled by the opponent. Let's say the opponent decides j as 3. And I decide the p, the initial string. So I pick a word where first half matches the second half, and each half has a length that is bigger to or equal to j. Since j equals to 3, let's choose the word 3. The same. Let's put j on top of it. I decided the same as j. So our full string word becomes 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And based on that, our length is 4j. Equals to 12. This is our total length. And based on that, the opponent decides a split. And I decide I decide the I to be 2. Let's do that. And covering all valid examples, the rule needs to follow uv is less than equals to j traps the opponent because they have to choose j equals to 3. The first two uv cannot go further to the right than the first 3 characters of the string, because we said that it's 3. So the uv is locked in the first 3. The first 3 characters are all zeros. This means that no matter how much opponent slices the string, the pumpable part v is guaranteed to consist only of zeros at the very front. Let's look at the setup. The opponent chooses the j3, just like we said. This is our word. And this is legally in the language because the first half 0, 0, 0, 1, 1, 1. This is the first w, and it repeats 0, 0, 0, 1, 1, 1. Matches the second half. So the both half are equal to each other. So this is completely fine. This is 3, this is 3, this is 3, this is 3. So it's just a copy of that, basically. But basically we have 3 on both. Now we understand that the opponent moved to split the word. They pick a split where uv is less than equal to 3 and v is bigger than equal to 1, or the length of v to be specific. Like in general cases it's r is bigger than or equal to 1. They are stuck completely inside the first block of zeros. So let's look at it in a real example. They say, oh, this is our u, this is our v, and in that way you will understand that the u gets there, the v part is this, and the w is the remaining part. Note that we use w as sub here just to avoid confusion, the substring variable with the language half word. So w is this, because it's actually also the second part. So that's why we say that sub, just to avoid that this is the substring variable with the language half word. Let's check our tracking variable. This is v, which is 2. This is legal because r is bigger than equal to 1 at least, and uv, the length of this is 3, which is also the same as our initial 3, which is also the same as what he chose, the j. So it needs to be at least that, and it is like that. So based on that, we know that the 3 is less than or equal to 3, and that works perfectly for us. Now our winning move would be that we choose the pumping multiplier I equals to 2, and in that way we duplicate the v section once. We say uv w sub, we duplicate it 2 times, and our new string becomes u plus v plus w substring, which becomes p to the power p0 plus 00 plus 00 plus our substring becomes 111 0 0 0 1 1 1, and this in total becomes 0 0 0 0 0 1 1 1 0 0 0 1 1 1, which in total becomes why you win against all the split. Let's check if this string can be split into two identical halves. Of course it can. Now see, oh sorry, of course it cannot, because see, the total length now is 14. It's 14, and if we slide it exactly down to the middle into two halves, if we slice the middle into two halves, like, of course this was the W part and this is not the same. So if we slice it into two halves, the first half is 0 0 divided by 2, 0 0 0 0 0 0 0 0 5 zeros, and then 1 1. This is the first half, and the second half would be this. Second half would be 1 0 0 0 1 1 1. Second half, first half, and the two halves are completely different. The left side grew extra zeros at the front, but the right side stayed exactly the same, destroying the WW pattern. You can see that it stays the same, while this is not the same. And we don't have the WW pattern anymore. What if the opponent chooses a different split? Because the rule says that UV needs to be less than equal to J, it forces V to be made exclusively of zeros from the first half, because 0 also has a J. And if he chooses, he cannot choose anything more than a J, because he has to choose anything from within it. And because our 0 has, let's say he says 3, he cannot choose anything more than 3. He cannot go to the next side of 1s, because it needs to be within the length of 3. Whatever he chooses, the split needs to be within this. And based on that, we trapped him in that. His split cannot be bigger than the J. It needs to be less than or equal to J, which forces him to exclusively make it from the zeros. And every single valid split is physically trapped within the first front of the string, and all valids will fail condition when pumped. The opponent has 0 safe moves, and the regular pumping lemma is proved, and I win.